So, second section, we're just going to have a look at how we can find different probabilities when we know we have a normal distribution. And to do this, we're going to use our Casio calculators. I've got the FX991EX here, and this is the one that all the Heybridge students should have. So it should be exactly the same for you as it is for me. Now, in order to show you how to do this, I'm going to use example 2. And example 2, we're told that we have a normal distribution and the mean of the distribution is 30, the variance is 16, which means the standard deviation is 4. We're not given any information about this distribution, we're not given any context, so we don't know what x is, but this is purely to highlight how we find probabilities on the calculator. So the first thing I want to do is make sure that you understand that to do every single question like this, you're going to start by doing a quick sketch so that you can get your head around exactly what these distributions look like and what areas you're trying to find. So we're going to do a rough sketch with a mean of 30. I have no scale on this at all, so let's say 30 is there. So my normal distribution is going to look something like that. Next time I'm probably not even going to draw the vertical axis at all because it's not really relevant for what we're doing. Now what we're asked to find in the first question is the probability that x is less than 33. So given our distribution, we are going to sketch on where 33 is. Now, bear in mind, if you're trying to put some kind of scale to this, we know that the point of inflection here is one standard deviation, which is 4, above the mean. So this is at 34 here. So we're going to be slightly below there, roughly. So there's 33. Now, the question is asking us for the probability that we are less than 33. So it wants this area here. So on my calculator, first of all, I need to go to menu and number 7, which is the distribution menu, press equals. And the one you're interested in here is number 2, normal distribution, CD. CD stands for cumulative distribution, which means the area up to a point or between certain points. So for the first one here, we're going to do number 2. Then we have to give a lower and an upper value for the calculator to tell us the area between. Now we know what the upper value is, that's 33, so that's easy. But the lower value, we don't have one at the moment. Oh, I have to go back through this, it doesn't like my arrows. Here we go. So the upper one is 33. The lower one, however, we just want everything below. So what we're going to do is pick a ridiculously lower value to make sure that we've just included practically the whole area. We know that once we go 3 standard deviations, so 4, 8, 12, below 30, so once we get to 18, we have got a bit below and 18 above, we've got nearly 100% of the values. So if I pick something ridiculously small, I know I'm fine. So we've got a lower value, ridiculously small. Our upper value is 33. We need to put in the values of sigma, which is 4. Be careful here, because although we write sigma squared there, we only want sigma here, so 4. And for the mean, we want 30. And we're told that that area there is 0.7733726476. Now, obviously, we don't want to write that every single time. So we are going to give all of our probabilities to 4 decimal places. So we'll put 0.7734, and we'll put in brackets afterwards the accuracy that we've rounded to, 4dp. Let's try the next one. Same distribution. This time they want the probability that x is greater than or equal to 24. So let's sketch our distribution again. This time I'm not going to bother with my vertical axis. 30 is there in the middle. Greater than or equal to 24. So 24 is down this end. And I want this area here. Now, I need to point out at this stage, here we had a less than symbol, and here we've got a greater than or equal to symbol. So we've got the equal to part on our inequality symbol here now. Doesn't make a difference whether or not you include the equal to bit. So I could just as validly write greater than there and rather than greater than or equal to. And the reason for that is this. What's the probability here that x equals a particular value of 24? What's that? Well, let's think about it. This value, 24, is one value out of its continuous data. So we've got infinitely many values along this axis. So we're dealing with a probability of 0 there. So the probability that it equals 24 itself is 0, which means the probability that it's greater than or equal to is going to be the same. So it really doesn't matter which symbol I use there. It will not change my final answer. So now we want a lower value of 24. My upper value now needs to go on as big as it can. So let's just do something really big, like 100. Keeping the same mean and standard deviation. So we have, for this one, 0.9332 to 4 decimal places. Okay, third one. We'll go a little bit quicker now. We're going to sketch the curve again because you are going to do this for every single question. Students always say to me, do I really need to draw it every time? And the answer is yes. If you can get to the point that you are getting every single one of these correct 100% of the time without making any silly mistakes, maybe I'll consider not letting you sketch the diagram. But until you reach that point, you will sketch the diagram every single time. So we've got 30 in the middle, and we're interested in going from 33.5, so somewhere about here, up to 38.2. So we're interested in that area there. On the calculator then, lower value is 33.5, upper is 38.2, and we have a probability of 0.1706 to 4 decimal places. Now, the final question asks me for the probability that x is less than 27 or, separately, greater than 32. So here's our diagram again. There's 30 in the middle, 27 somewhere over here. Less than 27 is that area. I'm going to do the other one in, no, I'm going to keep it the same colour for now. I'll just explain why in a minute. 32 is there. That's greater than 32. It wants this one or this one, which means we're going to add together those two areas. Now, I could work them both out separately using what I did here, but even better and even quicker would be to work out this area in the middle and subtract it from 1, because we know the total area is 1. So if we start with 1 and subtract this bit, we'll be left with those two bits that we're interested in. So we are going to do 1 minus the probability that x is between 27 and 32. So that's 1 minus. Now let's work that bit out. So lower 27, upper 32, and that's going to be 1 minus 0.4648. So 1 minus that. Oh, I'm going to have to go into normal calculator mode to do it on the calculator, so let's just do it without. So that's going to be 0.5352 to 4 decimal places. So it's quite straightforward to use your calculator. It helps you to work out the values really easily. Let's have a look at it with a question in context now instead. So example 3, we're told that an IQ test is applied to a population of adults. The scores on this IQ test form our continuous random variable x. And we're told, so let's write that down first, shall we? Let x be the scores, or the score on an IQ test. So we'll define our variable first. Now, we're told that these scores are found to be normally distributed with a mean of 100 and a variance of 225 or 15 squared. Now, we are also told that if an adult scores more than 140 on this test, then they are classified as a genius. So, first question is, find the probability that an adult chosen at random is classified as a genius, and give your answer to 3 significant figures. So, the chance that someone is classified as a genius means they have to get 140 or more. So to find that chance, we want the probability that x is greater than 140. So we'll come to our calculator And we'll go back to the distribution mode and normal cumulative distribution. Now our lower end is 140, need to put a really large higher end on, so I'm just going to go something ridiculously big like 500 because the IQ test doesn't go that high, so that definitely covers all bases. We have a mean of 100 and, oh, I keep doing that the wrong way around because it's the opposite way around to how we read it. So it's probably a good idea I did that because actually it shows you to not make that mistake. I'm going to pretend I did it on purpose. So here we've got sigma, which means sigma is 15 there. So I should put 15 in here. And mu is, secondly, 100. So the probability that someone is classed as a genius comes out as very small. We have 3.8 times 10 to the minus 3, so that's 0.00383. Now I did say give everything to 4 decimal places, so I could stop at 0.0038. I'm just going to go a little bit more accurately because it's such a small number, so that will do for now. Now, the next question is interesting. I'll just go back to my plain mode there for a second. The next part is really interesting because we're told in the next part, let me just go back and find the question on my screen. There it is. We're told that 20 adults take the test. Let's make a note of that. 20 adults take this test. And we've got to find the probability that 2 or more are classified as a genius. So what's the probability that 2 or more are a genius? Now, it's very tempting here to go, well, the probability that 1 is a genius is 0.00383. So 2 being a genius would be this times by itself. That would be wrong simply because that would be working out the probability that 2, one after the other, are a genius. But it doesn't want that. It wants any 2 out of the 20 that take it. So it could be like person 1 and person 2, or it could be person 1 and person 3, or it could be person 1 and person 10, or it could be person 2 and person 20. There are so many different combinations here. So what we have to do is stop and take a moment, step back and think about what's really being asked. What we're asked here is to count or work out the probability that a fixed number of people receive a classification. This is discrete data. So what we need to do for now is define ourselves a new variable. We've already used x, so I'm going to use y. And I am going to define y to be the number of adults who classify as genius. I'll just write genius there for now. Now, let's think about this for a second. So we are told that there are 20 adults taking the test. That sounds to me like a fixed number of trials. We also know that success in this test is being classed as a genius, and we know the probability of that happening. It's 0.00383. So that again sounds to me like we've got a fixed probability of success, which means we also have a fixed probability of failure, being 1 minus this. Success and failure just being the terms to represent fitting this criteria of genius or not fitting this criteria of genius. Each trial is independent because we're told that, because there's no reason for the one person's IQ to affect another person's IQ in this test. So we have a binomial distribution because it fits all the conditions for that. So we can say that y is binomially distributed. We've got 20 trials because that's our 20 adults, and the probability of being classed a genius in each trial is 0.00383. And given that distribution, we now need to work out the probability that 2 or more are a genius. So the probability that y is greater than or equal to 2. Now, we know that that is 1 minus the probability that y is less than or equal to 1. This is what we did last year in year 12. If that's unfamiliar to you, you need to go back and remind yourself of it. Let's work that out, shall we? The menu button and go to distribution, and this time we're going to go to binomial cumulative distribution here, so it's on the second screen down. I have a variable, so it says x, but obviously we've called it y, that doesn't matter. N was 20 because we have 20 trials. The probability of success on each trial is 0.00383. So the probability of being less than or equal to 1 is 0.99. I'm wondering if I've typed this in differently. It's coming out different to the book. Have I typed this in the calculator wrong? Let me just double check. Ah, yeah. X is 1. I should have put there. Haha, I've spotted it. There we go. I'm doing this bit on the calculator, the probability that y is less than or equal to 1. So I have to put 1 there. 20 trials. I've got my probability correct. Let's try again. That's better. 0.99733792666. Obviously I could do that to 4 decimal places, but that's fine for now. So we have 1 minus that is going to be 0.002. Well, let's go to 3 significant figures, shall we? So 0.00266. Again, because normally I do 4 decimal places, but because this is such a small number, I'm going to do to 3 significant figures. So what we're saying is out of 20 random adults, the chance of 2 or more of them being a genius is very, very small. So you have enough information to have a good go at exercise 3B now, which is just going to get you to practice the idea of the normal distribution in more detail, but also practice using your calculator to find different values and different probabilities using the area under the curve. Good luck, and I shall see you for the next video soon.